Hey, it's Chris. You got 3 minutes to talk about controls? Have you ever upgraded equipment for decarbonization purposes? Then the building still feels the same and the utility bills barely move? It may not have been an equipment problem, it could have been a sequence problem. In the real world, buildings waste carbon in quiet, boring ways. Fans run early and late because schedules never got cleaned up. Supply air stays colder than it needs to, so VAV boxes have to reheat all day. Economizers are disabled or never tuned, so you end up paying for mechanical cooling when free cooling is available. Pumps and fans run at fixed set points because that was safer at startup. And the end result is the worst combination: comfort complaints, higher energy use, plus higher emissions, even if you bought efficient equipment. Your control sequence decides how often equipment runs, how hard it runs, and whether systems fight each other. Carbon is tied directly to things like runtime, fan and pump speed, and simultaneous heating and cooling. If your sequence causes long run hours, high static pressure, and constant reheating, you're creating unnecessary load. When you fix the logic, you cut the load first, and that reduces emissions regardless of whether your building uses gas, electricity, or both. Decarbonization starts in the sequence, because the sequence is the building's behavior. Total building decarbonization can take a lot of effort, but a decarbonization-minded sequence, that's easy to come by. Make sure systems only run when they need to. Reset set points so you're not operating at worst-case conditions all day. Prevent heating and cooling from happening at the same time, and stage equipment more smoothly so you can avoid short cycling and inefficient operations. Those moves alone can cut carbon while protecting your comfort because the building stops hunting and it stops fighting itself. Take a common VAV air handler in a school. It starts at 5 a.m. every day, supply air is fixed cold, static pressure is fixed high. By 9 a.m. the south side needs cooling, the north side needs a little heat, and half the building was reheating air that was just overcooled. The boiler's running for heat, the chiller keeps running for the cold air, and the fans run hard to satisfy the worst zone. Now, change only the sequence. Add optimum start so that it starts closer to the time you need it. Reset static pressure based on the most open VAV box. Reset supply air temperature based on zone demand. Confirm the economizer and minimum outside air are correct. Reheat drops, fan power drops, cycling drops, the comfort gets steadier, and the carbon falls without replacing anything. Many buildings waste around 30% of the energy they use in day-to-day operations, and control sequence tuning is one of the fastest ways to reclaim a chunk of that waste. That's it for today. Thanks for spending 3 minutes with me. When you start decarbonization in the sequence, you reduce runtime, you reduce pump energy, and you stop heating and cooling fights. That lowers emissions immediately, before you electrify anything. It also tends to make comfort more stable because the system's no longer overreacting. Better logic usually means fewer complaints and fewer surprises. Reach out and tell me what building type you have. Maybe it's a school, office, or healthcare facility. We can talk about what might be best to trend to help you find the inefficiencies in your building. New equipment is great, especially the high-efficient stuff. It looks cool and may feel like you're making a big impact, but you don't always need it. With smarter sequences of operation, you can start improving your carbon footprint right away. See you next time.